Yeah, and then maybe one of the real hot topics still is trajectory clustering. So the pioneering approach is from 2007 here. So the idea is to cluster trajectories, yeah, group trajectories. And in 2007 here, the so-called Chara-Klus trajectory clustering algorithm has been proposed that aims at grouping sub-trajectories using a density-based clustering approach. So the approach is very similar, exactly similar actually, to dbScan. And the whole thing is a two-step approach. So each trajectory is first partitioned into line segments with a user-defined length. This is a parameter. And then those line segments are clustered into groups of similar line segments based on spatial proximity of the time slots, actually, of the time points. So the similarity of line segments is typically based on Euclidean distance between the segments, but it could be anything else, of course, here. So, for example, you can use a measurement that also considers time, which is not considered here. It's just space, but you can extend this basic approach here from 2007, and there are some variants that do exactly like that by just using a different similarity for line segments. So again, the line segment, the partition or the summarization in line segments is just because you want to get rid of the extreme details of trajectories that can be really detailed, so that you just summarize segments where the trajectory has, say, doesn't move too much, with respect to direction or whatever. So of course you can also think about a different first step here, a different segmentation, of course. Yeah, and then there are the so-called T patterns, so sequential trajectory patterns, proposed also back in 2007. So in that case, the authors aim at describing frequent behavior in terms of region of interest. So in terms of visited regions, and they want to consider both space and time now, not only space or not only time, so both space and time. And the whole thing is a three-step approach, so we just sketch it here. So the first of all, you try to compute regions of interest, the ROIs. Then you transform the trajectory into into sequences of regions of interest. So you come up with regions of interest here in the first step. That's just a visualization of this one here. So this may be one region of interest, this one, this another one, this another one. Then you can transform the actual trajectory, which is this one here, in a sequence of region of interests. So in that case, this trajectory visited, which is this one, this is A here, the yellow is A1 here, then it visited B, and then it and stays there, and then for two, two sequential stops, and then it visited C here. So you transform that into A, B, B, C. Still, storing the time slots between those stops or between those visits here, and then from this representation you compute so-called T patterns, which are sequences of regions visited during the same time intervals. So, for example, between A and B are 20 minutes, and a lot of trajectories have exactly this pattern A, B within an interval which is more or less 20 minutes. So that would be a T pattern, saying that some trajectories visit B after A within, say, 20 minutes plus or minus 5 minutes or something like that. That would be a T pattern in that case. And having a little bit a closer look at the three steps. So in the first step, you want to compute the region of interest. So regions with many trajectories, regardless of time. In that case, you just take the observation, the spatial observations, forget about the time slots, and then do a clustering in the two-dimensional, or in the space, yeah, in the spatial dimensions, yeah. And those observations that are close to each other, regardless of time, are considered to be regions of interest. Yeah? So in that case, it would be this one and this one here. Yeah? Yeah, and then you just transform the trajectory into the sequences of those regions of interest, which is, well, you select trajectories intersecting at least with two regions in a sequence in a sequence, sorry, and annotate the traveled time between the regions. Yeah, so that is easy. And then you compute the T patterns, which can be again done by a kind of a priori algorithm, because you just have to look for this sequential pattern here, yeah? Which can easily be done by a priori or stuff like that.